All right, hi everybody. Here's question 69 from chapter 9. We have a couple more. Ions to do in this case again for Lewis structures and such. So I'm going to show you two of them. We'll do phosphate and we'll do sulfite, and then again, same as before. If you have any questions at all, you can let me know. In this case, it's going to be a little bit different because we're talking about ideal structures in terms of minimizing formal charges. So that is a little different than before. Okay, so 5 times 8 here for total electrons is 40. Contributed, we have 4 times 6 is 24. We get 5 from phosphorus, which is a group 15. All right, so we had 18 makes 23. With these 3 extras makes 26. All right, just going to double check that, make sure that was right. Yeah, it's 4 times that is 24. Yeah, never mind, I was wrong. It's 24, but this should be 32. All right, divided by 4 gives us 4 bonds. All right, so long as it works out. Okay, let's try the simple way first. All right, this is definitely the easiest way. And let's see what we get. So for the formal charges for oxygen, this is oxygen with 1 bond and 3 free pairs, and we know by now that these are all worth -1. Formal charge for phosphorus, that is an unfamiliar one, so let's calculate that. It's going to be 5 minus 0 in free pairs minus 4 bonds gives us a formal charge of +1. So we got -1 on all 4 of these oxygens and then +1 in the center. That does add up to the number that we need, but we could improve this. You see in this formula that if this number was 1 bigger, this would be a formal charge 0, and that is definitely better than having the formal charge be +1 on something like phosphorus. So we can improve this by giving this thing an extended octet, like so. And then we keep these 3 oxygens with formal charges of -1. All right. In the double bond here, this is going to become 0, and now the phosphorus, because it has 1 extra bond over here, is now going to be 0. So this structure is more energetically favorable than this one over here, right? And you would have to calculate the formal charges we have here as we just did to know that, right? Okay, so we would bracket this off. This is 3 minus. You would have to then draw all of your different resonance structures, right? I'll do one, but I'm sure you can figure these out without me. There's O. There's O. All right, make sure you tack on your electrons. All right, that'd be 3 minus, and then obviously you've got 1, 2, 3 more to go after that, right? So on you go. All right, that'd be that for phosphate. Now let's do one for sulfite, or trioxosulfate if you prefer the IUPAC. That would make that last one tetraoxophosphate. In case you guys are fans of those sorts of naming conventions. All right, sulfite. 4 elements with 8 each gives us 32 in this case. We have 18 contributed from oxygen. Another 6 from sulfur makes 24. This makes 26. Divide this by 2. And that gives us 6 over that for 3 bonds. Okay, let's try that. 3 bonds again looks pretty straightforward. Oxygen, oxygen, oxygen. I'll have to add a free pair there. Right. I didn't count up the electrons. I forgot for the phosphate again to show you guys that, but that does work out too. So here we have 8, 8, 8 makes 24, plus that 2 there makes 26. We know all these are going to be minus, oops, I'm supposed to circle that whole thing there. These are all going to be -1, all 3 of these oxygens. We'll calculate for sulfur. All right, but this is exactly the same as an oxygen calculation because it's group 16 too. We've got 2 in the free pair. We have 3 in bonds, right, for a total formal charge of +1. All right, so not bad, not great, as per Chernobyl. We can improve this in the same way as we did the phosphate, right? We could drop this number down 1 by adding 1 more bond here, right? And so let's do exactly that. So we're going to have sulfur double bonded to oxygen. those two there. We're going to let sulfur keep its free pair. All right. All right, this thing still adds up to 2 minus. All right, we have 888 plus 2 makes 26. So that's great too. In this case, the formal charge for sulfur, right, with 2 in a formal pair and 5 bonds is going to be 0. Or sorry, and 4 bonds, excuse me. I was going to say that was definitely not 0. I was thinking I did this wrong for a second, but no, this is correct. And this oxygen is 0, so that is energetically favorable, again, compared to this one here. This would, again, have some resonance structures. Now you got a double bond, some single bonds around the central atom present. So here's an example of one. I'm sure of all the things that I stick in these videos, you guys do not need this thing shown to you. And there you go. And then you would have one more to show this one as well. Okay, so there's a couple polyatomic ion Lewis structures. Again, if there's any questions with the remainders, you're free to email me. Good luck.